Hello everyone. In this video, I am going to discuss about in information theory, joint and conditional entropy. Joint and conditional entropy means understanding information in combined and dependent events. This is called joint and conditional entropy. An icebreaker, how much do you know? And let's reflect how you ever compressed a file and wondered how much data was truly removed. Can knowing one event help predict another in communication system? Think of a real life example where two events are linked, like rain and traffic delays. We will build on these ideas to explore how information theory quantifies uncertainty in connected events. In session, main objectives on this topic is define joint entropy and conditional entropy in information theory. Compute both using probability distributions. Understand their role in data compression and communication. Apply concepts through real world examples and group problem solving. Connect entropy to broader applications in artificial intelligence, cryptography, and machine learning. In design thinking, first phase, empathize. Arjun, he is a data engineer. He needs efficient data compression without losing critical variable relationship. In define phase, we define the problem, measuring total uncertainty of two random variables and how one reduces the others. Then ideate phase, joint or conditional entropy models dependencies optimize encoding via variable relationships. Last prototype is predict user behavior from login patterns and device usages. In joint entropy on diagram is using formula, an entropy declared as H in two variables, that is x and y. We declared as H of x and x comma y for entropy. Joint entropy, that is two variables, we declare h and x and y, that is joint entropy. The formula equal to minus summation of x and summation of y, p of x comma y logarithm of 2 p of x comma y. P is used for probability. For joint entropy, log of 2 means 2 is the binary numbers 0 and 1. This is the measuring units. Here joining x, h of x, the first entropy, h of y is the second entropy. Here joint entropy means I of x comma y. This is the joint entropy declared in I information. Then computing joint entropy. How to compute joint entropy? The first step is list all possible outcomes of two variables like weather and traffic. The step 2 is build a joint probability table with p of x comma y for each pair. Step 3 is apply formula h of x comma y equal to minus summation of p of x comma y logarithm of 2 p of x comma y overall pairs. This is the joint entropy formula. Last final formula is the joint entropy. Then conditional entropy, knowing one or predicting another. What is h of y bar x? It measures the average uncertainty in y when x is known. Formula h of x bar y equal to summation of p of x h of y bar x equal to x. This is the conditional entropy formula. The real world insight is if knowing the weather reduces uncertainty about traffic, then h of traffic bar weather less than h of traffic. This is the key in efficient coding. Why send full traffic data if weather already tells part of the story? Here weather declared as H, two weathers. First weather one is summer season, weather two is rainy season. In summer season has two probability, light one and a heavy one. Probability light declared as zero point 0.9, then heavy probability declared as zero point 0.1. In rainy season also we declared light probability declared as zero point 0.2, heavy probability we declared as zero point 0.8. Traffic Y used to compute H of Y bar X. This is the diagram for conditional entropy, knowing one or predicting another. T-shaped learning, depth and breadth. Entropy chain rule H of x comma y, that is joint. H of x is the marginal, H of y bar x conditional. Vertical depth, master entropy formulas, chain rule and their derivations in information coding. Interdisciplinary links apply to machine learning, that is feature selection, cryptography, that is key entropy, and neuroscience, that is neural coding. Future scope, quantum information theory uses entropy to measure qubit uncertainty and entanglement. In summary and takeaways, key concepts are joint entropy, total uncertainty of two variables. Conditional entropy means remaining uncertainty when one is known. Chain rule is h of x comma y equal to h of x plus h of y bar x. These help design smarter, more efficient codes. Thank you for watching this video. Thank you.